Hello, Professor. Welcome to our presentation. Today, we are going to talk about the application, security analysis, and optimization of blockchain smart contract. So, firstly, let me to introduce this topic. Okay, so firstly, what is blockchain? So let's imagine there is a giant digital ledger spread across many computers, each recording transactions securely. Less blockchain. It is not controlled by one person or company, making it super reliable. Since it started with Bitcoin, which is very famous recently, its values has skyrocketed to over $1.8 trillion. At its core, blockchain uses clever math and special codes to ensure everyone agrees on what is happening. It tackles tough problems, like how to trust strangers online. This is crucial for things like online payments and contracts. So as we have known before, blockchain tackles some big issues. One of them is called the Byzantine general problem. It is like, how do you make sure everyone agrees on something, even if some folks might be trying to mess things up? Blockchain uses cool stuff like agreements among computers, fancy codes, and shared ledgers to make sure everyone is on the same page. Another problem it solved is called the double spending problem. Ever worried about spending the same money twice? With blockchain, that is not a concern. It keeps track of every transactions, making sure you can't spend what you don't have. Okay, right now let's talk about NFT, a hot topic in the blockchain world. I think everybody has heard about that. They're like a digital certificates for unique items such as art, music, or virtual assets. NFT has exploded in popularity, especially thanks to platforms like Ethereum. And speaking of Ethereum, it is the second largest blockchain system in the world. It allows you to send digital money anywhere and build all sorts of cool apps. One of its standout features is smart contracts. These are self-executing contracts with terms written in code, offering endless possibilities for new applications. Blockchain isn't just about fancy technologies. It is changing the way we trust each other and do business. It is making transactions fairer, more transparent, and accessible to everyone. As we look ahead, blockchain will continue to grow, shaping a more digital and intelligent future. However, there are some security vulnerabilities in Solidity language in Ethereum, and next we are going to talk about that.
Well, in this part, I would like to talk about the vulnerability analysis of smart contract. The first vulnerability I would like to introduce is the costly loop. At the beginning, we need to know Solidity development emphasizes optimization more than any other programming language. As a result, users may jam the network with infinite loops or use intensive computing to occupy a large number of network resources, and this will lead to costly loop. For the second part, I would like to talk about the overpowered owner. And we can see in this picture, in Solidity, we first need to set its owner to MSG sender and give it a modifier owner only owner which can restrict access to strangers. However, if the owner's rights are too large, once the owner's private key is leaked, then the attacker can use the attacked private key to control the contract. So that contract will belong to the attacker. That can be troublesome. Well, for the third vulnerability, I would like to talk about unchecked return values for low-level calls. In this picture, we can see when the send function is used to transfer coins, the return value of send function is not verified. If message sender fails to call fallback for the contract account, send function returns false and resulting in decrease in account balance but no assets. Well, in this page, I want to talk about denial of service. In selected smart contract, those attacks can block contract functionality by making transaction impossible to complete. For example, an attacker can use the rules of contract, such as a highest bidder in an auction becoming president, to maintain the president status by sending a series of tiny transactions. SRAM transactions require payment of gas. If the gas price is set high, other users may be unable to buy it due to the high costs. So this will lead to denial of service that can be troublesome. Well, in this part, I would like to talk about the optimal proposal of smart contract. The first proposal is to not store unnecessary data, because when writing smart contracts, we should only store what is needed for transaction verification. For example, data such as long description that are not related to the contract logic. This data do not need to be stored in the contract store. The second proposal is only Markov rooted start as state, because one way to mitigate state bloat is to keep only a 32-byte Markov root on the blockchain, and these two proposals can better the situation of costly loop, like we mentioned above. Well, for the third one, I would like to talk about is intermediate method whitelist, because use the whitelist method to keep a list of address, which can then be used for limiting functionality or other purpose. And the last proposal is optimize access control for roles, because developers can build a multi-user system with a complex hierarchy of users' rights. For example, developers can use RBAC cell contract to create and manage a modern shared multi-user platform through allocation of roles and permissions.
Today, I'm here to discuss a crucial aspect of the blockchain ecosystem security, specifically focusing on non-fungible tokens or known as NFTs. So I don't ask you one of the most important questions. What is the most significant in blockchain? Is it safety, the security, or the assets? So for my own opinion, I think the assets is the most important thing on the blockchain. In the realm of the blockchain, assets are not just digital currencies. They also include tokens, smart contracts, and various forms of digital rights. This brings us to an essential question uh, about it. So without secure access, the foundational units of blockchain loses their integrity and values. So let's delve into a common vulnerability into the smart contracts, particularly highlighted through the attack method known as the reentry. Just like what my teammates just introduced before, the reentry is the common issue that we always see in the smart contract. So imagine depositing a certain amount of Ether into the contract, let's say 25 Ethers for this example, and the attacker can exploit the reentry vulnerability to increase their Ether amount to this contract, leading to a successful attack. This is not only compromises to the smart contract, but also puts the associated assets at risk. So you can see from this picture, um, the the tag smart contract successfully transferred the ether from one address to another. So to understand this vulnerability is quite crucial. However, our goal isn't just to identify weaknesses. It's also to improve and protect. How do we achieve this by enhancing smart contract security and to withstand such attacks? So to improve, include mechanisms like the fallback functions, which reverse the contract to its state before reentry when an attack is detected. Additionally, implementing double insurance by adding two functions that are safe, providing just enough gas for the contract to execute the backup functions, thus preventing the further unauthorized contract calls. After implementing these improvements, we simulated the attack again and found that it failed. This picture demonstrates that our protection measures are effective in safeguarding our assets. So in this project, we have taken a comprehensive approach to the blockchain security by analyzing common smart contract vulnerabilities, stacking them in a controlled environment, improving them, and ultimately protecting both corporate and personal assets. The takeaway from our discussion today is clear. While the blockchain ecosystem offers groundbreaking potential for digital assets, it's imperative that we prioritize their security by understanding vulnerabilities, implementing robust protections, and continually improving our defenses. We can ensure the safety and integrity of our assets in the blockchain. So I think that's all we want to say today, and thank you very much.